Good morning, everyone. Today, Richard, Shanoa and I are going to talk to you about whether or not our coral reef ecosystems can be saved. Coral reefs are magnificent enclaves of biodiversity that provide important ecosystem services. Unfortunately, it's my job today to explain to you why coral reefs can't be saved. Some have said that coral reefs will suffer death by 1,000 cuts, and this is why. The list of threats to reefs is truly daunting. I won't have time to go into all of these today, but overfishing and pollution, including sediment runoff, are some of the most significant. Those on the right are those related to climate change. I've included cyclones there because there's some evidence to suggest that high-intensity cyclones are increasing with climate change. One of the challenges in protecting coral reefs is that many are found in the tropical waters of less developed countries. The Coral Triangle is a good example. This light blue area has been determined by scientists to have the greatest diversity of coral in the world. It contains around 1/3 of the world's reefs, so it's obviously of critical importance in preserving coral reefs globally. But like in many less developed countries, environmental laws and regulations in much of this region are weak and often poorly enforced. Those issues around poor governance worsen the problems faced by reefs in this area. There's rapid development of unregulated tourism, pollution, runoff from land being cleared, overfishing and illegal fishing, including the use of bombs and poison, and inappropriate coastal development. An unrelated threat facing this area is sea level rise. This illustration shows the rate of global mean sea level change from 1992 to 2013. You can see that it's not uniform, and unfortunately, the Coral Triangle falls within this worst affected area. With so many threats impacting on reefs, some threats can interact to amplify the effects of any one. For example, we know that disease is much more likely to affect stressed organisms. So when coral experience things like heat stress or declining water quality, they're more likely to succumb to disease. Crown-of-thorn starfish are a natural predator of coral, but they can be artificially promoted into plague proportions by influxes of nutrients into the water, often from sediment runoff. Increasing carbon dioxide levels in the ocean promote juvenile crown-of-thorn starfish, and overfishing depletes their predators. The complex structure of a reef is of critical importance in its resilience. So where the reef structure is damaged, it's more likely to amplify the effects of other threatening processes. The more complex structure that's intact, the better and faster it recovers from adverse events such as bleaching and crown-of-thorn starfish outbreaks. In recent years, we've seen an increase in the occurrence of high-intensity cyclones. So some reefs aren't getting the chance to fully recover before the next one hits. So where are reefs at today? Well, more than 40% of coral reefs in the Coral Triangle have been lost over the past 50 years. Remember that contains 1/3 of the world's coral reefs. More than 85% of the remaining reef is directly threatened by local human activities, and that doesn't include more broad-scale threats like those related to climate change. In the Caribbean, where reefs have been very poorly managed, only 1/6 of original coral cover remains. The Great Barrier Reef is considered to be one of the best managed reefs in the world. However, from 1985 to 2012, 50% of coral cover on the Great Barrier Reef was lost. So half of one of the best managed reefs in the world disappeared during that time period. The bleaching event in 2016 had a massive effect on the northern Great Barrier Reef, with 2/3 of the coral dying following that event. Coral reef cover globally has decreased by 50% in the last 30 years, which is just an astounding statistic. Damage to reefs is so severe that scientists have concluded it is no longer possible to restore coral reefs to their past configurations. I wanted to talk specifically today about warming ocean temperatures because it's the leading cause of coral bleaching, which I believe is one of the greatest challenges facing our reefs going forward. Corals are the result of a symbiotic relationship between an animal coral polyp and algal symbionts called zooxanthellae that live inside the cells of the polyps. While the polyps can catch live food, the algal symbionts provide up to 90% of their food. When the coral is stressed, for example as the result of high temperatures over several weeks, the algal symbionts create an irritant which causes the coral to expel them. The algae are responsible for the coral's colour, so once they've been expelled, the coral appears stark white, hence the term bleaching. No large-scale bleaching events were recorded before the 1980s, but since then we've seen 4 global bleaching events. The relationship between mass coral bleaching and elevated sea temperatures has been extensively verified, and as the oceans warm, we can expect bleaching events to happen more often. So how do we know that temperatures will continue to warm? We know that current atmospheric temperature increases are primarily related to anthropogenic greenhouse gas emissions. The climate system is slow to respond, so it will take time for us to see the full effects of past emissions, possibly up to 40 years. Gases can remain in the atmosphere for hundreds of years, and positive feedback loops are now being activated that might accelerate change, such as decreasing albedo with melting ice and snow and permafrost melting. Basically, reducing greenhouse gas emissions will dampen coral bleaching risk in the long term, but will not prevent it. Even with strong action to tackle climate change, more warming is locked in. So are we taking action to tackle climate change? Well, yes, we are. In 2016, the Paris Climate Agreement was signed, which aims to keep global temperature rise to well below 2 degrees above pre-industrial levels and to pursue efforts to limit the temperature increase to 1.5 degrees. This seems like a very good thing, but it won't save coral reefs. This is a graph showing the major climate tipping points, and that grey bar in the middle is the goal of the Paris Climate Agreement. You can see that the entire threshold range for coral reefs is within or below the Paris Climate Agreement target. So even if these ambitious goals are met, we will still lose coral reefs. Can reefs simply move poleward to escape warming temperatures? Well, the Great Barrier Reef would need to migrate 2,000 kilometres south in 100 years to keep pace with a 2-degree rise in temperature. Not only is it unlikely that coral can disperse at that rate, but the distribution of reefs today is likely the result of a combination of high light levels, high carbon and iron levels, and temperature that reefs need. With the shift in temperature zones, it's possible that this combination of factors may simply not exist anymore. Can coral adapt to warmer ocean temperatures? Well, it is true that coral have survived warm ocean temperatures before in Earth's long history. But the last time that they had to adapt to a similarly warm ocean, they had 100,000 years of gradual temperature increase to do so. The latest temperature change has happened in less than 100 years, which is simply too rapid a change for the coral to adapt effectively. So where does that leave us? The majority of existing coral reef ecosystems are likely to disappear in average global temperature rises much above 1.5 degrees above pre-industrial values. Or, in the words of another study, preserving greater than 10% of coral reefs worldwide would require limiting warming to below 1.5 degrees. Global temperatures have already risen 0.88 of a degree. Even with drastic emission reductions in the very near future, with the lag in climate system adjusting to the emissions, it's almost certain that temperature increases will exceed 1.5 degrees for many decades, even if they then begin to drop off. The tipping point for coral reefs is going to be passed. So in the words of Professor Emma Johnston, can science save a reef? I think the answer has to be no. Not the reef, not as we've known it. We are going to lose these reefs as they are now.